Wilfrid Sellers had created a manifest image of the world in which he had divided the world into 4 dimensions, 3 of space, 1 of time, giving us the space-time continuum. In contrast, many people have misinterpreted one of Einstein's letters to one of his friends whose son had died recently, where Einstein had called time an illusion, and people have latched onto that idea. I have to ask you, time is such a mysterious concept. So let me start with the silliest question possible. What is time? And is it real or is it an illusion?
Okay, so let me just say, I don't think time is mysterious. I mean, at a certain level, time is the least mysterious concept.
Okay.
Why do people say it's a mystery? So let's just be clear about one thing. And this comes back to the very beginning. We're cycling back to the beginning of the whole discussion. There are objects that are composite or derivative, right? So this Lego piece obviously has lots of different parts, and it has the word Lego, written on all these things, and it has a certain size and so on.
Mm-hmm.
And in understanding it, part of understanding it is understanding the parts it's made out of and how they're put together, right? Ultimately, it's made of atoms that are put together in a certain way that, reflect and absorb different kinds of light. That explains the color. And those atoms are ultimately made of electrons and protons. Protons are made of quarks. Okay, so we can kind of, for most things in the world, the question, what is it? Part of it, at least, can be addressed by saying what it's made of. Okay, what are the pieces? What are the elements or ingredients that go into it, and how are they put together? So we're used to that kind of answer. But immediately you notice, if you think about it this way, but wait, when you get down to the bottom, when you get down to the fundamental are exactly the things that aren't made out of anything else. Okay? That's what makes them fundamental. They're not derivative. They're not composite. Well, obviously you can't answer the question, what is it, in the same way. That doesn't mean it's mysterious. It just means it's not composite. I mean, time, it seems to me, is not mysterious. It's mysterious. If you think, well, what is time made of? Yeah, I have no answer to that. I can't think of anything more fundamental than time from which I can derive time structure. But that doesn't make time really all that mysterious. I mean, nobody thinks it's particularly mysterious to say that it's now, 90 minutes or whatever later than it was when we started this discussion.
Sure.
And time was going forward, time was going from the past to the future the whole time. And, time is an absolutely everyday concept. Now you can ask detailed questions about the structure of time, about the temporal structure of the world. And there's a kind of common sense way of thinking about time, which Newton used, parts of it. So one thing that Newton said, and he says this very nicely in a paper called De Gravitatione, he's talking about time being made of these instants, moments of time, moments of duration. So, snap my fingers. That happened at some time. And Newton says, look, that instant of duration is the same in London and in Rome and on the stars and throughout the universe. Meaning, when I snap my fingers, that moment of time exists, and something was going on just then over in the apartment way over there and on Alpha Centauri and off in that galaxy, right? It's a global, these instants of time are global. That's the way we intuitively think about time.
Yeah.
And these instants of time succeed each other. They go from the past to the future. We can measure, there's a measure of that duration in terms of seconds or minutes or hours. We make clocks to measure it, right? I mean, you've got time on your wrist. Time is it's not that. Now that's a theory of time structure. When relativity comes along, what happens in special and general relativity is you argue, no, that's not actually the correct account. Time has a different structure. The structure of time. It's not that time doesn't exist. It just has a different structure. The structure is given in special relativity and general relativity in a different way. And you get rid of these instantaneous moments, right? That's the main thing in relativity is you don't have this global instance of time. You get rid of that structure. And you do have a new structure called the light cone structure, which Newton didn't have. So you take away some of what Newton did have and you replace it with something that Newton didn't have. Yeah. And then in terms of this light cone structure, you can then, for example, formulate Bell's local causality condition. So that's a surprise. But on the other hand, okay, why should we think our everyday way of thinking about time is exactly accurate? Our everyday way of thinking about objects is that they're infinitely divisible. That's what Aristotle thought. Aristotle thought you take some water, you can cut it in half. And then you take that half, you can cut it in half. And you can do that forever, right? You can take an amount of water, you can cut it always into smaller and smaller bits. You might say, okay, maybe. Turns out that's not right. Once you get down to one H2O molecule, you can't cut it in half and still have water, right? That matter has as an atomic structure. That's not every day, but it's not that hard to understand either, right? Aristotle might have been right. Maybe you could keep cutting it forever. These are just things where the only approach is to say, all right, let's try and think of different clear conceptions of what's going on, and then see, can we get some data or make some observations that seem to tell in favor of one of these rather than another. So I mean, I think people way over, when you say time is mysterious, I really don't know. I mean, maybe let me say one more thing. If you're a philosopher all the time, you start reading Descartes' Meditations. Meditation 1, he raises all these skeptical problems. How do I even know I'm sitting by the fire writing, right? Maybe it's all a dream.
Yep.
Maybe there's an evil demon or God is fooling me or whatever. Okay. So Descartes manages to question even the existence of spatial objects. He never questions time. Even in a dream, time is going on, right? Even dreams unfold in time. They have a beginning, a middle, and an end. Even if Descartes is dreaming that he's sitting by the fire writing and there's no pen and there's no hand, still, that dream is going on in time and it has a certain temporal structure. So even Descartes didn't question the existence of time. So when people say time is so mysterious, I don't know what they think is so mysterious about it. We need to think hard about the kind of detailed, precise structure it has. And there are different possibilities there. Newton postulated one, Einstein postulated another. I'm doing some work that's postulating yet another. But is it all that mysterious? It's not that mysterious if you think there's this fundamental succession, which is the nature of time.
What's your postulate, if you're ready to share?
Well, what I'm playing with are ideas that at base, both space and time are discrete, so kind of have an atomic structure. They're not continua, which is what all modern physics is based on, the idea that they're continua, and you write down differential equations and so on. Maybe they're not. Maybe they're discrete. Well, the irony is, of course, whereas all the theories are written down in terms of continua, the calculations are all done on computers discretely. You put it on a lattice, right? You do a discrete calculation. Mm-hmm. And then there's some argument about why or why not the one should be a good approximation, or the conditions under which the one should give a good approximation to the other. My idea is that maybe at base it really is discrete, and the continuity is an illusion, as it were. Things at macroscopic scale, I mean, do they look continuous or not? Anyway, it's really fundamentally discrete. And the fundamental equations of physics should be written in terms of discrete quantities and discrete structures. That would immediately solve some problems, like there are these singularities and equations of standard physics that blow up, that go to infinity. And everybody understands that's a problem. And if you do things in a certain discrete way, you can immediately say it can't happen, because you're just adding and subtracting a finite number of finite quantities at every step. So it can't blow up.
So it's possible to break time down into discrete fundamental units.
Sure, it's possible. Yeah, everybody. I mean, even Zeno came up with these paradoxes of motion, and he had two sets of paradoxes. He said, well, if time is continuous, here's a paradox, like Achilles and the tortoise. And if time is discrete, here's a different paradox. The stadium paradox. I mean, you could go into details, but even in antiquity, it's not that hard to say, look, what do we know about time at the finest scales? Maybe it's continuous, maybe it's discrete, just the same as matter. Maybe it's continuous like Aristotle thought, you can always subdivide it, or maybe it's discrete like Democritus thought, you get down to an atom you can't divide. So it's not a surprise to say these are both possibilities. I think the discrete possibility has been understudied. That so much physics since Newton has been developed, and when Newton and Leibniz developed the calculus and so on, so much of it has been developed. Why? Because it was set in Euclidean space, and Euclidean space is continuous. And they assumed time was continuous. Maybe they're not. I think it deserves some consideration, because just saying that doesn't get you to a theory. There are many, many, many different ways of trying to implement the idea that space and time are discrete. I'm just working on one of them.